Third part of what we wanted to do today was actually covered, structured streaming. So if you look at, the Spark conf, you would realize that, of all the components that, was talked about at Spark conf 2 weeks ago, structured streaming was something that, had a wide coverage because, they've done something different, and we look at that. The one thing to remember though is that, 2.0 RC1 itself has not yet been kind of release candidate. So, as Madhukar said, you will think, and you'll also notice how quickly, like, even if you look at some of these SparkConf 2 weeks ago, the structured streaming APIs, between then and today they have changed, and 2.0 is not yet released, right? So, like, there were things like read and then you say stream. Today they've knocked off that and said read stream. So if you are playing around with those APIs, just be aware that it's actually not yet officially released. Okay. So what I thought I will go through today is basically we look at Spark Streaming 1.x and then what were its features, what was it good for, and areas of improvement. We will look at then how those are being attempted to be addressed, right? And some of the features in there. And then we look at them through examples also, but the examples are already on a GitHub repo, Sachin's repo. So you could take them and run, right? And then we'll try to summarize of how we're playing with it, what our thoughts are. The other thing that I wanted to mention that the structured streaming API is experimental in 2.0. And even if you, some of the things like, the sources and sinks that are there are very, like Kafka is not yet there as a source and it won't be there in 2.0, right? One of the primary ones. The ones that you can play with are really memory and file systems, and then when you're writing to a sink also, it's only Parquet, and you can only do, append only mode and stuff. So it's still a work in progress, I would say, right? But it's good to get a, hang of what's coming. So this is a big one. What is Spark Streaming 1.x? Right? Some of the things that you would have been talked about even in Madhukar's one was when you said Spark, 1.0, RTD, nice APIs. So here also we had a dstream API, which was nothing but a stream of RTDs, and they had many of the same APIs as an RTD, and then some of the APIs that were not there, you would do a transform and then use it, right? So the same, that feature was there, and you could do Windows, right? One of the things probably that, I don't know between Flink and Spark who came first with that, but one of the things that Spark Streaming specifically focused on was saying, this exactly one semantics that you wanted, right? And fault tolerance, so they cover that, right? There are things like, back pressure, and then, it integrated with whatever was the ecosystem, right? So even before I go, so Madhukar gave you a good, flow of, how the industry changed, right? You started with saying I didn't bother about structured data, and then you figured out in enterprises, most of my data is structured, or at Max it's always structured in the sense that, I want a schema on read. I don't want a schema on write, but I want a schema on read, but I still have a schema, right? And therefore how that, evaluated. Then if you saw all this, data frame, data sets and all those nice things, and if you looked at Spark Streaming, it was still stuck on, the dstream, which is nothing but an RTD and some methods over it, right, for Windows. So it's quite obvious that at some point, if the industry is going there, you have to bring, everything over, to data set and data frame, even for streaming, right? And that's what they have done, right? So you get all the nice goodies from there. Some of the other things, and I talk about this because, Spark Streaming was micro batch, no running away from the fact of that, but one of the things that they, as I said, initially talked about was, fault tolerance, right? And end-to-end fault tolerance from source, processing, and destination, right? But in Spark Streaming 1.x, though they said it's possible, if you wanted to write an end-to-end exactly once processing application, you, as the developer, had to do all the heavy lifting on the sync side, right? So if you receive data and you process it and you're writing it, if you want to ensure on the right part that you always process every message only one time, and this is because of failures that could happen in a distributed data set, in a distributed environment, because something is going to fail, you had to write the sync that was either transactional or idempotent, right? And that's not simple, right? As an end user, you don't want to get into, how do I write an end-to-end, right? So one of the main points with Spark streaming is structured streaming is trying to simplify that, right? Saying that I can give you end-to-end now, even the sync exactly once, and you don't have to do the heavy lifting, right? Like it was earlier, like they were running away from it, but now they're making an effort to address that. And let's see how good they could do that, right? So this slide I will skip. Quickly talk about it. If you wanted end-to-end exactly once, you had to ensure that your source could always replay data. So let's say I was receiving data and my receiver crashed. I should be able to go back and get the data. Some of the ways that you did in the earlier 1.x was you had a receiver that was always whatever data it got, it wrote to the write-ahead log, so therefore if it crashed, it went to there. But even during that period, you could lose some data, right? Spark by itself processing was always guaranteed to be exactly once, right? RDD guarantees that. And this was where, what I said, right? The sync, when you write output, right? Once you start, keeping your data to ensure that, there are two modes basically, one where you could lose data, but once I am saving data, how do I ensure that I don't give you the data 2 times, right? And you don't write it twice. So if you wanted to handle that, you had to basically ensure in your sync that, you somehow manage that you write it exactly once, right? And that was not taken care for you. What were the other things that they could improve, right? And here I'm talking about something in generic, not just Spark streaming, but in generally across the industry, right? So streaming comes with its own set of complexities, or in the other sense that when we all started writing applications out of college, we always dealt with batch. That was out, right? You had a database, you wrote to it and you received it, right? That's batch. And we always knew how to do that, right? With streaming applications, it's not the same, right? We talked about this, fault tolerance that you have, how do you do exactly once and stuff like that, right? So as we talked about it, it was hard, right? And the other thing was, even in Spark streaming, you talked about Lambda architectures, and the dstream had most of the methods that you wanted as batch, and then there was an overlap between the RTD API and the dstream API, right? But when they pitched that, there have been more advances in that. So you've heard of Apache Beam, right? So this is like you write your application spec once and it can generate both for batch or streaming, right? And I think I spoke about it earlier, right? There's a paper even out there that how it claims that Spark is not really Lambda. If you actually look at it, some of the use cases, there's a lot of code that needs to differ, and it's a long way to catching up. So I think they've tried to even address that, because if you looked at the design docs, those were openly points that they talked about, saying, people in Beam, tell us that we are not doing this good, so let's see how we can do an API. So I think they've done an effort to that, to make it more simpler for the complex use cases. Spark didn't have support for time, event time processing, especially when you're doing streaming. You want to process, your logic needs to process data based on the time the event was generated. Let's say an IoT event, right, that you get from a device. You're not going to take the time that that data has to come to the Spark system, right? And you don't want to process it based on the time it actually received in your system, but actually the time that it happened at the source, right? So Spark streaming didn't have support for that. And I think many people have discussed that the way the APIs were, you had like batch interval in the API and stuff like that, and how you did your windows in 1.x Spark streaming, right? You're so tied to processing time that how would they introduce event time, right? And therefore, that was definitely one thing, and they've addressed it, and the change in API also gives them a neater way to handle both event time and processing time, right? And then finally, this was another thing, right? Streaming applications run continuously, and then at some point you you want to change a small, calculation that happened, right? You want to stop the query, make a change, and restart it. Those were not there. And in streaming applications, people want to do that, right? Because it's continuously running applications for months together. They've started making an effort to that. So today you can individually in an application, streaming application, you can individually start queries, stop queries and stuff, right? They've not yet gone into can I change a calculation without recompiling and stuff like that. But that's an area they tend to want to go to. But at least from the API perspective today of starting, stopping it when it actually crashes, rather than the app crashing, there was a termination in that query, I can still get the exception of that stack trace and my application doesn't crash kind of a thing, right? The final thing, of course, we all know that Spark streaming is micro-batch, right? Here, at least, they've made some efforts from the external API, there's still a trigger time, but you can even skip to do that. The thing is that I've heard, and they've publicly said that, Matai and students are looking at how, have the same engine, but still do message-by-message processing. So that's something that's still in research, but yeah. The fact that the API now doesn't clutter you up with processing time is something good, right? So please go to Spark Streaming 2.0, right? It made ultimate sense, right? If you looked at Madhukar's session, the earlier one, it would definitely be built on the SQL engine, right? Because you heard of data sets, data frames, how you handle the memory structure and everything, right? So they built it on top of the SQL engine, right? No guesses for that. The other thing is that your primary batch API now, as we figured out, is going to be your data set, right? So streaming also now gets it, right? So it's easier to share a lot of code base much better than what you did earlier. And even all the enhancements that you get with the optimizer in data set, now you get even with your stream, right? So if you're doing a join where after the join you put a filter, then the optimizer knows that push the filter first and then do the join. All those things, nice things come in. And the challenge, of course, is still, right? This is yet to be seen, right? As you say, streaming applications are complex, right? Have they reduced the complexity as a total? We look at that, and time will only tell, right? So without jumping into, let's dive in, right? I'm not going to run the code examples here. They are pretty simple. They are in the repo. You can take and run them, right? But I'll just show you some code pieces, right? So what did they do? So they said that, we said that it's all this complex like streaming. So we are used to this batch, right? So batch is nothing but, I have an input table, I run a query, I get a result table, right? This is it. So the idea was, can we make streaming even follow the same paradigm, right? So this is what you have in Structured Streaming 2.0, right? You have the same, it's still an input, much like here you have an input. You give a query that you run, it could be whichever API you prefer, data set, actually writing an SQL, the DSLs, data frame, whatever you want. You write it the same way. You do get a result table, right? And then that result table, you choose how you write that to your destination, right? The simplest case could be that I do some aggregates and then I update a database, right? So this would be, let's say, your external database, MySQL for simplest case, or it could be a Parquet file, right? So you get input for a period of time, you run your query, you get a result and you write it. And then you have this thing that, a trigger period, right? At the next interval, right? You got in some more new data, again you run that query and you update this table. Now there are two ways you can do it, we'll come to that. It could be that I just do an append to this table, or I have the entire result, right? And then that again gets written out to external, right? And then this keeps processing. So at the next period of time, again you had more input data, your query runs on that, right? You produce the result table and then you update, okay? This is called a trigger. So you would set, still like the old way, you would set that it needs to run at a given fixed period of time, or you could actually skip that. The good thing now with Spark is you could tell it, run it as fast as I can, right? It still runs one batch after the other. The batch needs to complete, and then it will run the next trigger into it. Maybe I should not use the word batch. You run the next trigger. But you could simply not give a trigger and say you run it as fast as you can, right? And then it will continuously try to run it. And in case there is no data that comes in within the next cycle, it actually doesn't run your query. So it's not like, it's running your query all the time. Before it starts up, a trigger interval of the fastest it can, it checks whether any new data has come in, and then, it processes it. Okay. Good on this? Any questions? You can ask it anytime. So let's look at the programming model, right? So I think Madhukar had the word batch here, the word count batch, which we all joked about. And it was the same. So let me see how many were sleeping or not sleeping. Am I using a data frame or a data set here? Data frame, right? Yeah. Frame, right? Because I'm still using Word and all that, right? Yeah, I never, coming from when I'm preparing this from a streaming backend, I didn't bother much about, should I use data set or data frame, and will I get type compatibility and all that stuff. All I wanted was, it was easier to not have extra code .as string or .as thing. And I even got stuck off when it was a single field, .as string was simple. Then when I had 2-3 fields, I couldn't get how do I do it. In the square brackets, do I put 2 column names, or I have to put 2 square brackets and give 2 different column names? So I just ditched it and I said I'll live with data frame. Okay, right? The good thing that later I figured out here was, I think Madhukar did the flat map. I figured out a new where there's in the data frame this thing called explode that can do the same thing as a flat map. So here is basically I'm exploding the string into multiple words by the split. Same thing, but I learned a new syntax and group by. Right? So this is what you're seeing, and then normally maybe you would just do a df.show, right, in SQL. Here I've also, even in the batch, I've ensured that whatever I processed, I ran a query and the output again, I wrote it to a particular folder. Here I use my local system, and generally it would be an HDFS, let's say you're writing and Parquet and you write it, right? And now you look the same as your streaming application. The only thing that, from an API perspective, you said read, you say read stream. So then he knows, I want to run it as a stream. And then when you said write here, right, you say write stream. And the new things that come in is basically the output mode, right? I'll talk about this. And you put an output mode, and then the checkpointing, of course, that's not necessarily tied to streaming, but you want fault tolerance and stuff, so you actually set a checkpoint location. And then to actually start running the query, much like in the earlier dstream, you actually do a start and then you say await termination. So you wait for it. So it doesn't start running till you did this start, right? So this part was all same. The only thing that came in was this new output mode. And if you went back to the previous slide, the output mode, so this is happening every time, right? I run a query, I get the incremental data, I query it, and then I calculated my result table, right? And how this result table should be written to my output sync, right? These modes is basically what control it, right? So the various modes that you have is basically, today they have something called complete, append, and update. If you follow the design docs from earlier, they had something called update in place and stuff like that. But right now I think it's these 3 only that they talk about. There might be an update in place, but I don't know. So what does complete do? Complete basically ensures that this result table that you get every time after you run the query, that entire table is returned to the external storage, right? Whereas in append, only the new rows that came in get written. So you get to control what you want to do, right?
Sachin,
yeah.
Yeah, so in data frame streaming, so where is the time interval here? Time interval streaming? Where can we put that?
Yeah, the biggest thing that people hate with fast streaming is micro batch, and I like the fact that maybe from an API perspective you don't specify it. So typically here there will be a dot trigger, okay? I skipped it. You'll say a dot trigger, and then you say your time period. Processing time, 1 second, 1 minute, whatever. But I wanted to show you that in 2.0, you don't need to set that. You can tell Spark Streaming, run it as fast as I can. So I'm not given a trigger. I didn't say trigger. So when you don't say trigger, Spark Streaming will try to run it as fast as it can. So once it finishes the first trigger, it will immediately start the next trigger. Right?
Yeah, my second question is that for structured streaming, can the source be a database?
But how, the question for, see, you can go and write a new source, much like these streams, right? I wrote a Kafka source, I wrote a MQTT source, you can write. So the source API is the same as your data source API earlier. The question is, that I would ask for your question is, you can implement one. So the question is how you are going to implement. Simplest case you might say, like an ETL, I would read the update log of a database and pull it. You could do it.
Or maybe after every 5 minutes I want to trigger data from database.
You could do it, right? So if just to answer your question, I don't think I have a reference to that in the slide. The earliest, the simplest way to write a source, there's something called a socket or text input source, or a socket input source stream that was committed very recently to, and I actually have a link to that. Okay, I'll just show it to you as simply you ask. Just to give you a quick one. Yeah. So if you go to this Jira, right? This was an IBMer, Prashant, who's my colleague, who's a committer, wanted to do a socket-based source for structured streaming, and there's a discussion on it, right? And there was some discussion, but I'll come back to it. But if you go to the Jira, you'll see another Jira that actually links to this Jira, and from that you would actually see the pull request for the final text stream source that was written by Mate. Okay, let me just get back to this. Yeah, and it's just one file, right? So you read that file. It's very simple. There are basically, for the source one, there are basically two methods that you need to implement, right? One is the get offsets and then get the batch data. So at every trigger interval, what happens, right? Or fast as it can at trigger interval, it calls the get offsets, right? To give the new offsets. Right, and once you have the new offsets, you compare whether your previous offsets, new offset and data are there, and it says yes. And then if there is a difference between the offsets, it will call the actual batch to get the data. So the point that I'm trying to give you, since you wanted something for a database, just look at that class and you'll figure out very simply how to implement a source for structured streaming, and you could write one from a database based on how you want it, right? Like you said, I will every 5 minutes query and do a delta and find it. You could do it like that. Whether it's the optimized way of doing it and stuff, that I'll leave totally to you, the implementer. But the interface is there and you could write it. Right? Yeah. Okay. Right. The other mode that actually comes in, we talk about the complete, where every time the results are running written to external storage up to date. The next one is append. That is only new data that came in since the previous batches. Only that is written to your sink. And the update is when this one is only added, so this even updated host. This mode is not yet supported. So these are the modes that are given, and I'll talk about what built-in sinks there are on the next slide, right? But there is no built-in sink today that yet supports update. Right? Only these two are there, with again only Parquet and a few debugging that I'll talk about it. This update is probably when you're writing to a database, right? It's very easy to implement this. Assume I have a primary key, so I got data and then I took that primary key and said update that row in the database. That's the most common one that you do, right? They give you some built-in sinks for this, right? But you could actually go and write your own sink and then you decide the logic of how you want to implement it. There are a few subtleties in here that initially playing with kind of a thing that. So if you actually did an aggregate query, right? Let's say the most common use case that we talk about, right? I'm calculating the top 10 tweets that are happening, every 5 minutes, sliding window and stuff. So I actually run an aggregate query because I'm saying group by or something like that, right? Once you do an aggregate query, the only output mode that you can write as of today is a complete mode. Right, you can't, once you have an aggregate query, you can't say give me append mode. It gives you an error. And similarly, when you do a non-aggregate query, you can only use append. You can't. Which this one kind of makes sense, but this one I'm not too sure at this point whether it's not clear whether that's a restriction that will stay or that's just a point in time, right? And what sinks are available right now, I'm not talking about sources, but only sinks, because we talked about the new thing, is these are the ones that are there. There's the file sync that you can run to write to Parquet, right? It is fault tolerant, right? So they've implemented. The thing is, it's only append mode, right? It can't do a complete mode, right? Because you can't update that file or whatever. This is something new that came in where you have to implement some stuff. There's a memory sync. So the memory sync actually what it does is it that result table, it keeps it in memory on the driver. Okay, and there's also a console sync where it will actually write to the console. Both of these support an append or complete only mode, right? The main thing to remember again, these two are only debug, right? These are not meant for use of production. I talked about 2.0 is still experimental, so not production. But even this, both these is only for debugging purpose. The reason is that entire result table, it every time pulls it to the driver and stores it on the driver in memory. So you'll very easily run out of memory if you're actually running with huge amount of data, right? The main thing that, given that these restrictions are there in 2.0, you probably want to write a for each sync very simply to actually test out how it works, right? And this is something custom that you would have to write.
Both of them keep it.
Yeah, both of these. See, the memory sync is, it keeps it in memory and it's available as a table. The only good thing is, I never showed you, but in the previous time when you write stream, you can actually say dot name, give a name for your query, let's say foo. And then in another SQL, you could actually refer to that query. You can do a select star from that query. And as that changes, your query data also will change, right? But it's still only table. Right, and this one it actually keeps it in memory and actually writes it on the driver, the console it writes, right? So pretty much restricted, but given that structured streaming is a work in progress, no one's saying in 2.0 you can use it in production, right? Again, if you look at sources, today you have JSON and text sources. So you could do CSV, I didn't have a slide, sorry I missed that, right? But some of the real things that you want, things like Kafka or Kinesis, not yet there, right? So it's a work in progress, right? So this is more like, at least you gather knowledge of what's coming rather than something that you can use in production today, right? The next part that I wanted to talk, and Madhukar also put in it, spoke about this was windowing, right? So with streaming, what's difference apart from these other things? Your actual program logic between a batch and a streaming, the only thing that's going to differ is really in streaming. Most of the time you'll have a window on which you operate, right? Batch you will have windows, but for the use case of time series that Madhukar talked, right? But if you're not doing time series, the difference between your batch and your stream would be these windows, right? Because in stream you don't live off all the data. So you do sliding window and tumbling window. And if you looked at even the dstream API over and above the RDD, the main thing was these windows and then the for each, right? So you do have a new window, and I won't talk about it. And the way you use it is like, the point that I'll talk about is like earlier, the windowing in dstreams, you couldn't use it on an RDD, right? Now they have a window function that you can use in both. And the way they have used it is, you treat it as a simple aggregation function, right? So how you did a dot group by, and then you can bring in your window period, right? I won't cover this because Madhukar covered it, and I think he covered this start time from a perspective of that example he gave you. My week starts from Thursday or something, so I wanted to do that, right? Monday, Tuesday was a holiday for the stock market start time. So the question that you will ask is, the start time, what does it mean in a streaming time period? Does it mean when my streaming application started, kind of a thing? No, it doesn't mean that. So I'll give you an example. Let's say I'm doing maybe I have it in my example later. I want to do windows of 20 seconds, right? Slide by 10 seconds, right? So when data comes in, how do I start? Do I put, starting from 00 to 010 or 020 is the first batch, or I want to start it from 1, 2, or 3, right? So the same thing you can do it there. But the point that I was trying to make is don't confuse this start time with the earlier day stream timing that you gave, right? That should not be confused.
So start time is applicable for only for the first frame or for all subsequent frames?
It's it will depend on how you want to, like when I took that minute, right? How you want to have your sliding window minutes, right? So for once you start with 10, all your data, your windows then in that sliding is going to be, let's say you took 00 as starting, right? I never gave a starting, so that means start from 00. So always from that period, you'll always have your windows saying for 10 seconds sliding 00 to 10, 10 to 20, 20 to 30. So that gets fixed, right? So it's not depending on when your application started kind of thing, right? Whenever you have data, whether you're doing it on event time or processing time, I'll show you that, your sliding windows are going to be in that period kind of thing, right? Yeah, you use it, the nice part is you use it in a group by clause, the simple way, right? So this they have really thought about, right? So the question then you said was, okay, in 1.x I had this processing time, and you showed me the window function, and you said there's something called event time where you want to do the processing based on the time it happened in there. So let me give you an example, right? Let's say it was an IoT example. You had a room where you were looking at one sensor giving you temperature and another sensor, giving you something else related to temperature. Let's say it's like, for simplicity say, let's say, whether once it gets too hot and you have smoke, the sprinkler is going to come, right? So the temperature sensor feed is coming to you, and even from the water sprinkler, the feed is coming, whether it's turned on, yes or no, right? In the normal system in Spark streaming earlier, so it has to travel on the network from the sprinkler and the sensor to your Spark system, right? And based on that, timing could get lost. One packet might reach early, the other one. So how do you ensure when you are comparing, what the temperature and what the sprinkler is, you need to ensure that you are comparing data from that same window period. But in processing time, the normal Spark streaming 1.x, you couldn't do that. There was no way you could do that, right? When the data are received, that is the batch, and that batch you are comparing, right? So with Spark, so with time event, and this is nothing specific to Spark, with any system, event time, you basically need to have a timestamp inside your data itself. The data that's coming, when it left the sensor itself, let's say, put the timestamp on it, right? So the time is there within that, right? And you use your event window, you create your window based on that column, right? So automatically it's doing that, right? And when you have sliding windows, the same data will go into multiple windows also, you have to realize, because it's an overlapping and sliding, right? So that's important to remember, right? So it's nothing the same, nothing great, right? If you look at here, I did something here. I was working with JSON, right? And JSON doesn't have a timestamp format, so even though I write it in that format, when I read it, it's not a timestamp, and you can't use that on a window. So I learned some more SQL with Spark. This is how you actually, use the cast, and you cast it into a timestamp, and I did that, and you can do this, right? How do you do that on processing time? It's very simple, right? In your data, at whichever point you want, just do a current timestamp. So you got your processing time, and then you actually did a window on your on that column, and then. So it's a neat way, whether you're doing processing time or whether you're doing event time, the model is the same, right? It's not different like other systems. So how do you handle late arrival? So the biggest problem that you'll talk about when you talk about event time is late arrival. Right? I'm creating my batches for this, right? So let's say the temperature sensor sends its data and it came first. Should I keep waiting for 10 minutes for the sprinkler sensor to come? That's a question, right? There are two ways. One is, let's say if I'm updating a database with what happened on time, and it's okay even to the data arrived late, but I can go and update that later, the fact, right? Let's say I was taking counts of within this time period, what was it, right? So obviously the data never arrived to me. So at that point, it wouldn't have that data. But let's say the data came back to me later. when I have the complete mode, automatically it would update that row. It's an aggregation and you're updating that row. So that row would get updated at that point of time. So that's one way of nicely looking at it. The other thing that comes about is what if most of these systems, especially I think if you do Fling and even others, they have this thing called a watermark. So when I'm processing a batch based on event time, I'm saying, okay, I'm processing this period. There is a given time I'll wait for all data within that period. And then I cut it and say do the processing. That's called the watermark. And if data comes later, then whatever we handle. But that watermark controls when I will do the processing in that event time, right? Something similar like that, I don't know. With this model that I talked about, where it's a column in the field, right? You could simply do a filter. Let's say if data, I don't want to process data if it's 1 hour late. I could have simply put a dot filter where current timestamp greater than event time timestamp greater than 1. Right? Theoretically, you could do that. But there's also Spark is working on watermarks, and they said not in 2.0 but post 2.1. No much details on that. If you look at the design doc, there is some ideas that talk about it, but nothing yet there, right? Or how they would do the watermarking. And we are back and talk about a little of how fault tolerance is now in structured streaming, right? So again, we have been doing these meetups for a long time. I think the first meetup we did on Spark streaming was back in December, and that video is back there. You can actually go back to it. And it actually talked about how actually the fault tolerance works in Spark streaming, right? I've taken in Spark 1.x the best fault tolerance that you could have was this direct Kafka API. So you had Kafka as a source and Kafka could replay, and therefore you had very good exactly once for source and exactly once for processing, right? Sync of course was not handled, right? So the way it worked was basically, and I believe that this model has been taken and now extended to structured streaming. So what happened there? So you had a driver the way they changed it here was you have the driver program that will actually at every period of interval go and query the latest offsets from Kafka, right? And what those new offsets were actually fixed for that batch, right? And that information is then written to the checkpoint location. So in case your program crashed during the processing, I will go back and pick that batch, and since I have cut off what those batch offsets were, I will process those offsets alone and then continue my program, right? Then the actual executor read those data from here. So let's say after reading what this processing, it crashed, I would go to my checkpoint location, read those offsets, and this guy will read it and it will work the same way, right? So that was the best exactly one stuff that you could do in 1.x, right? What happens in 2.0? Fault tolerance in 2.0 structured streaming has changed a little, right? They put the same model. It will apply to all sources right now when you're doing it, right? They moved it to the same, that the driver will actually go to the source and get the offsets, and those offsets will be written to, currently it's HDFS, it will be checkpointed to HDFS, right? And if it crashes, it will use. So basically it's the same model. What they actually added, the model has what I said about Kafka Direct, right? And then they actually, when you set a checkpoint location, they're actually doing a write-ahead log. So every time, whenever a trigger interval happens, it gets the offsets, right? And it immediately writes that entry into the write-ahead log. And if you are playing with a Spark streaming program, structured streaming, you set the checkpoint location and you can go and see what it's writing there. So you will see monotonically increasing. There will be a 0, 1, 2, 3, 4, 5 files created, right? So the nth file there basically is referring to the data that is currently being processed. The n minus 1 is the trigger interval data that's already written. So, and the numbers will be monotonically increased. So whenever a crash occurs and recovering, he just starts reprocessing from the nth entry. Because he knows that the n plus 1 entry is what has been idempotently written to the sync, and just take that and rewrite. Okay? So a little change. I think it's simpler, but this is what they have done. The one thing that you require is, I think I have it on the other slide. If you are writing a sync, the requirement is that you write a sync that is guaranteed to be idempotent. So what's the requirement for idempotent? Anybody? Yeah, so idempotent basically says, even once I gave you some data to write, if I call you back with the same data and tell you to write, and you write it, your data should still be consistent. It should not. So the simplest way to think of it is an update to a database, right? Update some column set on some value, right? That's an idempotent, right? So you have to ensure that, right? That's a requirement for syncs in Spark Streaming 2.0. And this brought me to the other one, right? So Spark structured streaming is that fault tolerance of exactly one semantics is something that they are striving for, and they talk about saying that in Spark structured streaming, mostly they're going to support only sources that can actually do a replay. So things like Kafka and Kinesis will be there, right? All other ones, I don't know, maybe the first thing that you do in the common architecture is whichever your sources that doesn't have replay, you first write to Kafka and then you process some Kafka and Spark Stream, or you write to Kinesis, right? But if you go to this issue, you'll see a discussion around that. This was the last one that I had, which was talking about managing streaming. So I talked about all these problems earlier, and now they've come up with an API. So once you do the write stream and you space start, you get back a query object, and each query object has a name, it has an ID. You can actually do an explain, stop. For that particular query, you could say await or termination. You can get the exception that happened when that query terminated, stuff like that. You can actually query the sources and the sync for the status, right, to get the offset. Today, when you do the source offsets, there's an offset field inside source status, but it's very opaque. I don't know whether it makes sense to actually expose those offsets in a nice way. Like for instance, for Kafka, it will certainly make sense, right? But I don't know if you are reading, let's say, from a Parquet or from something else on HDFS, what those statuses would mean. But definitely, if you wanted to get an idea of in each trigger interval, what were the offsets that were processed and stuff, that would probably have to come in here, right? There is also, I don't think I have that. Much like you had a listener interface for batch, right? It'll say start batch, stop batch. There is also a query progress interface. So there is a query structured streaming query listener or something, right? So every time a trigger interval is completed, it gives you a query process. The query process update, so it will give you a query update kind of a thing, where it will give you even these source statuses and sync statuses at that point of time, so you'll know how much along have you progressed, right? Even if you never had the query from the Spark session itself, you could do these queries, right? So you could actually go and say streams and figure out which are active and get these stuff and do this. So that's also there in the management API. So with that, I'll kind of summarize, right? It had to go to data sets and data frames on the SQL engine. Don't talk about that, right? The window is good. The fact that now there is no streaming context, it's just the Spark session, that's good. The optimizer is good. The code share between that will be good. I don't know if you compare to Beam, whether it's become more code sharing, so the Lambda architecture is there or not. Maybe that's an exercise that somebody could do, right? The little bit of a downside, but that's given based on the design patterns that they could select, was initially when you start, at least for me, it was now you have this output mode, sync type and query type. All those three you need to line up and say, okay, can I select this output mode for this query type for this? It takes some time to wrap your head around that, right? If you wanted, for a particular query, you wanted a particular output mode and it's not supported, what do you do? Right? And this is also called out in their design docs, that the design that they've chosen. They try to simplify it for the most common use cases. Let's say I'm updating a database and stuff. So out of the box, end to end, it works. But it's definitely not going to cover everything, right? Especially on this output mode and sync type and query type. The other thing that you do is it's all runtime exception. So I wrote an aggregate query and then I said, I want output mode append only, right? And only when I run my program at runtime and say analysis exception, you can't do these two. So it's a little bit frustrating because it's a combination of three things that you have to get right, and there is no compile time check. You have to go through 2 or 3 things to figure out what's the combinations that's possible, or you need a book page that says what's possible, right? The other thing is, the other thing is many of the queries also, the doc talks about it. All SQL queries can't be used today, like so you can't do a limit on your query, right? But those are things that maybe in 2.1 they will work because this is experimental. So there's a list of what queries you can't use on streaming and stuff like that, right? And that's in the docs too. And so basically when you talked about this and when you're playing with this and you find that's a restriction right now in 2.0 and they're still yet to build some of their proper things, there's this for each thing that you could implement, right? And so the way you do it is rather than saying, I don't know what was the previous one, where you put the console or the memory, you can say for each and you give a class that you implement and you have to implement these methods. You do an open and a process and a close, right? So for every trigger interval, the data that's going to come, he will call an open and a close for matching, right? And then the process is where you'll actually get the data and you do what you want to do with it, right? The important thing to realize is that this program that you write, right? This class, the instance of it is actually shipped to the executor. So it's running on the partitions, right? So you shouldn't do things like here you go and open your print writer. You see that only the print writer is opened here, right? Because if you did that, then your class will not be serializable and you'll fail, right? So this is running on the executor. All your logic you can do only within your open and your close, right? Don't do anything outside of it that's not serializable, right? But so if you want to actually run some workloads, so one of the things that we were doing in IBM was trying to see how good the latency is. It's micro batch. So the first thing is you look at latency. How good latency is in structured streaming compared to dstreams 1.1. And we were using the console sync till we figured out that it crashes out of memory because it's pulling everything to the driver. And what's our only option left as of today to get some numbers is probably using this. So we avoid that problem. So yeah, that's all I had. You have any questions? Yeah, there's a question there.
I have a couple of questions. Do we have these streams here in 2.0?
Oh yeah, so those still exist.
Okay.
I don't know whether they marked it deprecated or even it might be unofficially marked deprecated, but those are there. So your old D streams are still there. They're not thrown away.
Okay. So I use Flume Sync as a source to Spark streaming.
A source or a sink?
The Flume Sync as a source to
exactly.
Spark streaming. Do you see that being added to 2.0?
So let me go backtrack to you in the previous one. The D streams is there, but in 2.0 many of the sources that were part of Spark were thrown out, except Kinesis and Kafka, right? And I think Flume was brought back. You're right. So Flume was brought back. So you're happy. Flume is there. That is the official release will have it. But if you are using MQTT and stuff, though DStream is still there, those sources are no longer packaged with Spark. So Spark 2.0 will not have a MQTT DStream source, right? What has happened is those got moved out. But the good thing is actually IBM has done a good thing there. IBM went ahead and started a project called Apache Bahir, where all those DStream connectors that were moved out is moved to Apache Bahir, and we will make releases of that. Or it's actually an Apache project. It's not IBM, but IBM is driving that one. So you will get releases even if you are using MQTT and stuff. You will get those releases for DStream from Bahir. And if you do write an MQTT source for structured streaming, I don't know, maybe even an MQTT, you have a file where you can actually persist data locally, right? If it makes sense and you do that, the most common place that you would contribute that would be Apache Bahir and not Spark, right? So Spark is not going to keep those sources, right? So hope that answers your question.
Thank you.
I have a question regarding for example, currently I have written an application, streaming application, which is Microbat. So will there be any further development? If there is no development, does it mean for the developer to rewrite the code again if he wants to continue with his Spark going forward?
Two things I would say that. See, they're not throwing it away, right? It's going to be there. It will be deprecated over a period of time. Whether it will be removed, I don't know, right? But the question I asked you is, what is the application? Does the application go to more complex things that you want to do event time, right? So if you want to do event time and stuff like that, obviously, and you want to stay with Spark streaming, you have to come to structured streaming, right? So for an app that is, you're not making changes, right, and you're for sure you're not going to go beyond requirements that are not there in dstream, it's probably still very safe to be on dstream, I don't see, because they're not going to throw out dstream in a very short time kind of thing.
But one always looks for improving performance, right? So whatever we have achieved till now, we are not going to get anything new.
Sure.
And
Yes.
and coming back to this again, are there any performance benchmarks and comparison? How will getting an idea how much better it will perform compared to that?
So some things are very obvious. Madhukar talked about the performance benefits that you get from data set for those two things that he talked about, right? The serialization stuff. All those automatically apply here. Right? They never applied in a RDD or even a dstream. So you get that.
I can see the benefit of unification and more abstraction here. Getting
even performance-wise, I'm not saying it's going to go from micro batch to real-time streaming. That's not going to happen. But apart from that, still there's going to be performance benefits, right? We talked about Catalyst and stuff like that. So some of the things that will be important is, I think, and this was there even in the SparkConf, right? He showed you that I wrote a streaming application without, and of course it was a custom code base where he could turn off those optimizations that you talked about, right? The code generation optimizations that they have. And then you could see that the streaming application was lagging. The source data was collecting. The moment he turned on those code gen optimizations, it automatically caught up, right? So if that was the exact scenario, and you were on dstream, you wouldn't have got that boost up, right? So obviously you're going to get a boost up.
I have two very basic questions.
Yes.
So one question is in this Spark streaming, so assume for some time interval that data is not coming, and we are saving the RDs as Hadoop files. So there will be empty RD saved there. So in Kubernetes there is still empty, or how it is there?
Yeah, that's a good thing that I said. Given that they moved to this model that the get offset executes on the driver, so the way the internals work is it checks whether there is data, right? And only if there is data, it actually goes to the next step. So those empty stuff creating will not be there.
Okay, and one more question. So I haven't used the data set yet. So in the RDD we save the Hadoop files as Hadoop files. So we can see the data either tag for JSON or whatever, we can see the line by line. So how the data looks like when we save the data set to the Hadoop? I'm in the HDFS.
So it's the same. You have to pick the mode, right? So you saw that right stream, you say Parquet. So it depends on what is. Today, if you are writing to HDFS, the only thing supported is Parquet. So you have to go and look at your Parquet files.
Okay.
And it still has your column information, your data set, what columns, it has all that. It's in Parquet. You can't write to JSON today. So if you say JSON, they don't have. I showed you that source only Parquet is supported on file system.
How the schema is set for structured state?
That's the same as data set, right? Let me go back here. Yeah, this one. I didn't show you the full sample probably. So the question was, how do you set the schema when you are doing Spark streaming, right? Structured streaming. Did I have that? I marked up. No, I missed it. So actually, there's. I was using JSON here. So one of the things that you have, and probably I don't have, but it's definitely in the repo that's checked in that I gave you a link in the start, right? You can say spark.sql.schema.inference is equal to true, And then if you are using JSON, you need, when you start the Spark streaming, if you have one file in there, it would take that JSON schema and fix your schema. If you did CSV also, you could do the same. So in data set and data batch, whatever you did, how you set the schema for a CSV file or whatever, right? Those APIs that you call, all those still apply here. So you set it the same way.
Yeah. Well, I have a problem. Like say for example, there is a log file from which I want to pull the data and process it using the streaming. So like every 10, maybe every 1 minute, there's some data that is accumulated in that particular log file. I need to just pull that data and give it to the streaming and process it.
Yes.
So here in the first place, like just to get that, the data after every 1 minute from that log file. So what mechanism you have?
That's implicitly happening. So maybe my programs are not so good. So when you say read stream here, right? There will be a file stream source, a file stream. Earlier you had a file source. Now you have a file stream source. So there is like the data source, right? And I told you there are two APIs that you need to implement. One is the get offsets, and then for those offsets, give me the data. So the way what at the back end is happening, here I have not set a trigger interval. So I have told Spark, run the program as fast as you can. So let's say, I start my program and immediately Spark, this source will go to will call you and say, give me the offsets that you have for now. Right? So you will now at that point write code to read your log file, figure out what are you're starting up, so you just take everything and return those offsets to Spark.
So you mean I have to write the program separately that every time you see the temp.txt, so that you should give me the fresh data of the last 1 minute?
Yes.
So
only I'm telling you, that's what. But the thing is that these sources that I talk, the file stream sources, are already implemented. So if you are reading from a Parquet, you are reading from a CSV, or you are reading those, that is already source. There are built-in sources.
Okay, so that means I can assume that every one.
Not everything. See, your custom log format, there is no reader. Then you have to write that reader.
I have to write the reader.
Yes, if the reader. If it is a standard format that there's a built-in source in Spark structure streaming, then you will use it out of the box. If it's not there, you have to do that. So it's same, like even in 1.x it was the same, right? There were sources for MQTT, for JMS, for Kafka, for Kinesis. They are doing the same thing. So those same thing need to exist, but now they have to be written to the structured streaming interface that I talked about, which is nothing but get offsets and get batch data.
So by default, if I don't use any external thing, how often that will get
So even now when, let's say I'm reading off, maybe I can go into the thing. How often it's read? How often it's read is controlled by here.
How often it comes from the source into the temp.txt?
No. See, here what I am saying is, this is my input directory and there is a file stream reader. So as quickly as I dump a new file in this folder, right, and what was my period interval here, it will get read. Right?
So, but if it is some custom requirement, I have to manually take care of that.
Yeah, if it's a file format that is not supported already, then you have to write it. But you don't have to worry about the timing. Because as you, a guy who's writing that source, don't worry about the timing. The timing of how quickly it's called is controlled by the app guy and Spark. So he says the app programmer told Spark to every 10 minutes, I want this trigger to happen. Then minimum every 10 minutes it will call your source to get the delta.
Yeah.
Yes, that will happen. So that's the app programmer. The final guy who wrote the app programmer controls how quickly or fast he wants it.
Yeah, because here I want to pull it after every one.
Yes, so that's also what is happening. I don't know. I don't know whether I want to hold up everyone. I can run some of the samples here itself, where I'll show you that I dump a file in the directory and then the result will come up.
Okay.
Right? I don't know, and it's been a long day. I'm not too sure I actually want to take time for everyone. But if you step back here, I will show you running up. Once everyone disperses, I'll show you the running up. Yeah. Yeah, I've already spoken for an hour and it's 2 o'clock. So if we don't have anything, I think we'll wrap up so that You guys can actually go and have a huge lunch. And